Checking the conditions and example. The calculations we've been doing to find confidence intervals for two proportions are only valid when the following four conditions are met: random and independent, large samples, big populations, and then we have a new one, independent samples. Note there's an exception to number one, and so for certain types of problems we don't really think of number one as being a condition we have to check. So we'll do that in the next video. Okay, so how do we check these conditions? We're going to look at an example that we have already seen in a previous video, and it deals with 2,000 men and 2,000 women who were selected at random, and we asked them, do they believe embryonic stem cell research is morally wrong? And 0.23 or 23% of the men said that they believed it was wrong, and 0.21 or 21% of the women said they thought it was wrong. We found a 95% confidence interval for the two populations to be negative 0.046 to 0.006 in the previous video, and it turns out that this confidence interval is only valid if the conditions on the previous slide hold. So what we're going to do in this video is check the conditions. Condition one is random and independent. In particular, both samples have to be randomly drawn from their populations. So let's take a look. It says 2,000 men and 2,000 women were randomly selected, and so we're told that each group was randomly selected from the population. You can see it right here. And then also the observations are independent of each other. So if you look at these 2,000 men, their opinions are not related to each other in the sense that the chance that one man might think that stem cell research is wrong doesn't affect the chance that another man might think that stem cell research is wrong for this group of men. Same thing for the women. So we're going to assume that that's true. So number two, large samples. Both sample sizes are large enough that at least 10 successes and 10 failures can be expected in both samples. Remember, when we talk about successes, we mean just like the number of people who have the opinion of interest. So a success here would be thinking that some stem cell research is wrong. It's the thing that we asked people about and found a proportion about. So how do we check that we have at least 10 successes and 10 failures? We look at n times p and n times 1 minus p for each group. This is very similar to what we've done before, and we need to check that these are bigger than 10 for each of the two samples. Now, n is the sample size for each group, and so that's 2,000 for both the men and the women, and then p is the sample proportion for each of these groups. So for the women it was 0.23, and for the men it was 0.23, and for the women it was 0.21. So for the women, we would do 2,000 times 0.21, check that this number is bigger than 10, which it is. And then we would do 2,000 times 1 minus 0.21, and we check that this number is bigger than 10. So both of these numbers are bigger than 10, so we're good for the women. We do the same thing for the men. We take 2,000 times the 0.23. This number 460 is exactly how many men of the 2,000 thought that stem cell research was wrong. And so it's bigger than 10, so we're good. And then this number right here, 2,000 times 1 minus 0.23, there's a typo I'm just noticing, so I'll fix that later. But this number, so that's not supposed to be a 0 there. This number is also bigger than 10. This number stands for the number or the total number of failures or men who think that stem cell research is not wrong. Okay, so all these numbers are bigger than 10, so we're good, we can move on. Now, big populations, if the samples are collected without replacement, then both population sizes must be at least 10 times bigger than their samples. We have to check essentially that 10 times n, or the sample size, is smaller than the population size for both of these groups. Now, for the men, 10 times n is 20,000. What's the population size of men? Well, we assume that our population of men is just all the men in the United States. Usually they don't tell us what the population is, but if we're interested in, like, do men think this research is wrong, do women think it's wrong, and we're doing a study in the US, then we can assume that the population is just all the men in the United States. And so since this number 20,000 is smaller than the population of men in the US, there's like so many more men in the US, we're good. So we want this number to be smaller than the number of men in the United States. Same thing for the women. If we do 10 times 2,000, we also get 20,000, and this is way smaller than the total number of women in the US. So these two numbers have to be small enough compared with the whole population of interest. In other words, the population of interest has to be much bigger, big population compared to this number. Okay, so this is the fourth condition, and this is one we haven't seen before, and it's independent samples. So the samples must be independent of each other. This means that when you take the sample of men and the sample of women, the opinions of these people have to be independent of each other. So we're going to assume that we take a random sample from different populations, so population of all women in the US, population of all men in the US. And so in other words, because this was random, it's not like we're taking, like, say, couples, married couples, or people who have some connection where their opinions would be like the same or different for some specific reason. So if we select them at random, there's like so many men in the US, so many women in the US that we're not going to get a bunch of, like, you know, two pairs of men and women who have like opinions that influence each other. We assume they don't know each other well, which would mean that opinions of these people would be independent. Okay, so that's the 4 conditions. Before you find these confidence intervals, you have to make sure that you check them, and this video covered how to check each of the conditions.